Hello, hello.
I'm going to show a little primo.
Yep.
Enjoy, have fun.
Thank you. See the primo. How is it going so far? Everything's happy? The coffee was good? You know, now you got me. I'm sorry. Like, oh, you were waiting for me. You have no idea. Just to clarify, I'm Italian. Means 30 minutes for me are different from you. Like, we have different, range. So let's start with, first of all, who I am. Oh, sorry. Oh, the next slide. Yep, there you go. So first of all, building tomorrow world with digital twins edge AI. I think we already spoke about digital twins this morning. What I'm trying to give you is a sense of real use cases. What we do is actually building digital twins and solution around digital twins. So this is all about. So a little bit about me. Alex, Festa is easier. That's because my parents were really funny and they decided to call me Alessandro Francesco. It's super easy, especially when you have to fit the signature spaces, I'm a product manager. I'm working at the SmartCow. If you can see the logo, basically this is a cow that has been taken by an alien ship. I was telling to Ahmed that everybody is asking us, oh, this is a really cool logo, this is a really cool name, how you get that? And this is the most boring story ever. Is like, the answer is, oh, we need a name. That's it. I'm sorry. I know. We should work more on the marketing side, probably. Anyway, what I do here, what we do actually here, SmartCow is an AI engineer company. So this means, basically, that we try to solve customer needs through AI. Whether it is working with hardware, whether it is working with software. So we combine hardware and software to find a solution for our customers. They have a use case. We try to apply our competency, our knowledge, to figure out that. We are a multi-geographical company. Our headquarters are in Malta. We're back in Italy, where I come from, France, India, Singapore, Taiwan, where we have the factory, where we re-engineer the hardware. What kind of hardware you're probably thinking of? Well, we are long-time NVIDIA partners. We are not working only with NVIDIA, but mostly with NVIDIA. Just to give you a sense of the relationship. Means the elite partner logo means we are one of the only 8 worldwide partners on Metropolis for smart cities. There's over 200 partners there. We are one of the 8 elite partners. We are preferred partner for Jetson. Means what we do basically is taking the Jetson devices, the edge devices, re-engineer those devices, and basically put them under specific kind of hardware, like cameras. So instead of a dumb cameras, we have a smart cameras that can do the analytics directly in the cameras. And of course, we work with NVIDIA Omniverse. That is mostly what I'm going to talk about that. But before going that, I almost forgot. As Italian, if you don't understand my English, no worries, just follow my hands. There are 2 exits in Discord, and then you say no worries about that. So if you are distracted by my answer, just give me a sign. It's pretty typical. But because we are in Romania, I think we are pretty close in terms of understanding each other with hands. We do a lot of products. So this means if you as a customer, you have a problem, you have a need, we can figure out a solution for you. But often, because the solution, or better, the problem is common to many others, we combine this in a product, in a turnkey product, either as a software product, either as a hardware product, either as a software and hardware combined. So from edge solution like Ultron, that is a sort of advanced PLC, let's say like a controller that actually can control multiple things, video, cameras, robots' arms, and etc., up to software solution, right? For example, like Fleet Tracker, that is basically a solution to manage a multitude of devices. When I say multitude, I'm speaking about millions of devices. Why is that? Well, because our main focus, one of our main focuses is smart cities. But what makes a smart city complex? what is the problem with the smart cities? Smart cities are complex because are the outside real world. If I go outside of here, there's a plethora of things I need to collect in order to make it a smart cities. Or bigger. I'm not sure if, well, actually, we have two problems. First, my video here is going to power off. And the second one, yes, can we make it a little bit bigger, maybe? Not sure if it's possible. Nope. That's it. Well, I will explain, no worries, I will explain this. So, what this means. Okay, what makes a city a smart city? There are things that are visible to you as a person, and there are things that are invisible to you. Like, if it is 8 a.m. and I have to pick up my kid and take it from my home to the school, my problem is that I could be stuck in traffic in my car. It would be really better if the cross light could be a sort of a smart cross light. They can understand the flow of the traffic. And so maybe I have a longer green light in certain traffic junction or shorter green light in some others. If you can understand that there's a junction and one of the sides is completely empty from cars and the other one is completely stuck by cars, so you can basically prioritize these. Also, can recognize the fact that if there's an emergency vehicle, like an ambulance, it should give you the green wave everywhere it's going. Or maybe it could be a smart parking, for example. If I get into the parking, I'd like to not stop there collecting the ticket, probably waiting for the button to raise, and it never raise, and I have to call the human and say, hey, please, can you get in? Or maybe, should I get out, please? But maybe can use a camera to recognize my plate and let me check in and do an advanced pay system. Or maybe there are other stuff, like, for example, the pollution collection. If we see that actually the pollution is rising, then maybe I want to, for example, divert the traffic. Maybe I want to stop certain roads to be traffic aware. This way I can literally drive my city to be a more livable city. So a smart city is really complex because it's made by multiple sensors in the order of thousands, if not millions of sensors. It's made by heterogeneous sensors, camera, pollution sensors, and so on. But it could be also by other kind of things, like the analytics you make there, the prediction you make there. It's simple to say, hey, I like to understand, I like to build, a traffic light system, so when the traffic raise, basically, I can create the green light wave. But the reality of the problems is, how do you know that? How do you simulate that? A small difference could be that if the traffic is 8 a.m. in the summer, is way different in, well, it used to be different when we have snow back in, do you remember the times when we used to snow and not 20 degrees in November? But, no, it's very cold this November, 18 degrees, so I'm not expecting that. But that's the difference. Is knowing the traffic is low for a completely different reason than a summer. And I need to understand that. I need to evaluate that. And even further, oh, by the way, there's this small problem with this knowing that my cameras is completely covered by snow. And guess what? The cameras all of a sudden doesn't recognize anything, and we are all stuck in a beautiful red light forever. That's a smart city. Welcome to the new world. So how we can do that? Can we make it more simple? The short answer is no, but let's say, beside the marketing answer is yes, absolutely. That's why I'm here. No worries, trust me. I'm Italian, you can trust me, We have a long history of trust. Okay, we have a family, you all know. If you don't trust me, I don't know. If you have a horse head on your pillow tonight, ask me. But no worries. So can we make it more simple? Yes, we can. I mean, we try to do it. Now, before I actually explain this and how we can make it simple, let me ask you something. How many of you already interacted with metaverse, already been in the metaverse? None of you. One, thank you. How many of you ever played with Minecraft or Roblox? So you've been in metaverse. Roblox is a metaverse. It's probably the biggest metaverse right now. What is a metaverse? A metaverse is just, I think Katerina gave a definition before, if I remember, but metaverse is simply a virtual world. It's a virtual representation of the world. But there are multiple different kind of metaverse, or if you want definition of metaverse. We have industrial research metaverse. For example, NVIDIA is building Earth 2, that is a simulation of the real world to understand things like earthquakes or wind direction, etc. There's the industrial metaverse that I will speak about in a minute. But gaming, Roblox is that. Whenever you log in on Roblox, I'm not playing with Roblox, I have kids. It's a different story. So yes, I'm on the other side of your world. Yes, I'm an old guy, by the way, but that's another story. When you log in on Roblox, you pick up a word. And when you pick up a word, you decide how to live for that day. There's multitude kind of things. Some are really classical games, some other are like really simulating things. Again, I'm speaking not by experience, but listen, my kid, he was playing with one of his friends about being a family with kids and etc. and on some Roblox servers, I don't know. That's the kind of metaverse. Minecraft is a kind of metaverse. And you can tell me, oh, Minecraft is a game. Have you ever heard about Edu Minecraft? Edu Minecraft is not a game. It's a gamification of a way to learn things. You can study physics, you can study history, you can study whatever you like there, and it's an educational program. It's a metaverse. Using gaming and gamification as a way to interact with that. Then, of course, there's Meta. Let's not speak about Meta these days, but anyway. And then that is more the consumer fans of the metaverse. It's the idea of why we should run a physical meeting when we can have a virtual meeting. And we all know that it will never happen that a pandemic will hit us for a couple of years and we will be stuck in our room speaking with our colleagues remotely, right? Never happen. So, but this is a way actually to approach the world. I'm working in a company where my engineers are sitting in Malta, Taiwan, Singapore, Italy, and France. There's no way to be in the same physical meeting. There's no way actually to be there. Of course, I can do the typical Zoom call, etc. But the metaverse could be an alternative way to do that. That's why I'm saying Meta is not that wrong in the end. It's just a way to have a different experience and interact in a different way. An easy question and answer to do that is like, have you ever tried to do whiteboarding in a Zoom call? God save you, because it's like no sense. My solution, and this is a real case, is having a physical whiteboard and a camera attached to it so I can draw that, but there's no interaction. If I'm in a metaverse, I can potentially do that. But what if a company can combine all those things, creating a platform, or if you want, a protocol that allow you to build all this stuff all together? So that's the concept of NVIDIA Omniverse. It's a platform, but it's also a protocol. It's a way to allow people to use different tools at the same times to interact with the same results, the USD that Katerina was telling us before, so that any change made on any single different tool will be reflected on all the others in exactly the same real-time scenario. This way we can literally rebuild things as a team, but up to a realistic kind of environment. This is the concept where you can build industrial metaverse, gaming. If you remember from a Katerina speech, I think she showed something like there was the simulation of a human at some point. And there was this picture where she had the USD, where she was explaining the USD layer, where you can actually see from the skeleton up to the complete result. That is perfect for gaming. But it could be also digital twins. That is what I'm talking about. And of course, there's a consumer. So that's the result. Different solution, different software, different vision. The gaming, the industrial, the consumer. So let's try to figure out these, let's try to explain this in a practical scenario. Let's say that we are in a smart city project and we want to build a smart parking system. One of the things that you have to take care of on a smart parking system, and these more relevant things in the smart parking system, if your camera needs to recognize a plate, it needs to recognize the plate. And how many variables you can think of on that? How a plate is done? A plate could be yellow, white with a blue piece on the left for the EU plate, green, if you come from Norway, for example. It could be square, it could be single line, it could be double line. If you're in Italy, I'm not sure in Romania, but in Italy in the past there were black double line with yellow numbers. A plate is, well, this is always pretty hard to explain to my US friends. The typical European plate, especially in Italy, is not flat. I think it's flat for the first 30 seconds when you buy the car. 30 seconds after, your plate starts to be like that. Why? Because your friendly neighborhood in front of you just decided that in order actually to fit the parking lot, you have to really push, then you push on the other side, you push back, you push again, and magically you fit the parking lot. Okay, let's call it a creative way of parking, but that's a problem. Why is a problem? Can you think of why is a problem? Look at where I am now. I'm heated by light. And if I'm flat, the light has a certain condition. But if I'm not flat, the light has a completely different condition. And my model is being trained on a flat kind, not on the dent. And that means that basically it can fail. The accuracy goes down. That's one of your first problems. I can give you another problem that is related to the way actually you have to train your model. Did you remember the slide in Ekaterina's slides where she was showing pictures from the NVIDIA AV system? There was cars and etc. Where those cars were taken, what was the angle? The majority of those cars were seen by the car itself. It's a dashcam. It's a low level and is from this side. Now you're training a model to recognize a plate and it does a 98 accuracy on that. Oh, super cool. Then we release the model, we put the model in the cameras and the cameras all of a sudden got less than 60% accuracy. Why is that? Because the camera is here. The angle is different. The light impact is different. The condition is completely different. And the model has no idea how to recognize the plate at this point. Your problem is not your code. Your problem is not the way you build it. The problem is that you did not remember that your camera is in a different position from where you expected it. The problem is you just paid 10,000 euros for a data set that is basically unusable. That's the problem. That's the starting point. We spoke this morning about Hugging Faces and the beauty of Hugging Faces. I can use 3 lines of code to actually use a pre-trained model. We spoke about this morning about the new relevant AI trends. And we saw the sport bets, and we saw all we can use those models actually to make our lives easier. The problem is that your starting point always and ever is the data you have. And in order to make simpler your use case, you have to rely on the data set. And the data set have a lot of problems. There are omitted values. The bounding boxes are not. Do you remember the dogs and cats? Please, labeler, draw a box where you see dogs and cats. Does it mean you're drawing one box for the dog and one box for a cat? Or means you're drawing one box where there's a dog and cat in the same picture? Or just the cats and the dogs explicitly are found? Those are the omitted values. Those are the duplicate example. You are basically labeling twice, 3,000 times the same picture. It's useless. My model cannot be trained against the same picture. Bad labels. Dogs and cats, one box. And your model all of a sudden will think about, okay, there was the tiger dog. Bad feature values. What are the features you're looking for? Oh, please, also I need all the single flavor color, etc. Well, with me it's fine because I'm blind color, so who cares? But normal people outside of me basically is like, maybe they care. So all these things makes your data set, your real world data set, not necessarily applicable to your model. And that's lead to a low accuracy of your model. The problem is that you cannot control that. And by the way, is your data set enough? You spend 10,000 euros for a data set. Fine, data set is here. You train the model. Fine, everything's fine. Your model is even have a good accuracy. So how is it possible that 3 months later your model all of a sudden has a bad accuracy? I'll tell you why. Unknown features. You start to see things that was unexpected, like my parking lot perfectly recognize all the Romanian plates, and then Alex the Italian show up with his Italian car, get to the parking system, and all of a sudden you have no idea what my plate is, and I'm not paying your parking lot. How many of you buy cars from Germany, just in case? That's an unknown feature. Now, what you do? What you can do then? Why we don't have a better data set? Why we don't improve the data set? So let's start to look for a data set that include also the Italian plates. And then you have to have a data set with US plates, and German plates, and France plates, and et cetera, and et cetera, et cetera. And by the way, did your data set include also pictures from plates with snow, rain, ice, with dent, perfectly flat, newly won, old one, and et cetera? It's a recursive problem. You have to keep improving the data set, and that's make the data set, I wouldn't say unusable, but really hard to keep up with your model. Oh, sorry, what happened? That's why, not me, but let's say, okay, the marketing version is people smarter than us. The non-marketing says is like people we pay thinking they're smarter than us, like the analyst firms, but actually they have a sense of the market. This is a serious version. They say by 2024, 60% of the data used for development of AI or analytics project will be synthetic. What is a synthetic data? Katerina gave us a perfect technical definition this morning, but in a nutshell, synthetic data is building data as close as to the ground truth, to the real world, that could be used to train your model. This means also there could be different flavor of synthetic data. It's not necessarily realistically comparable to the outside world because it depends on the use case. So what we thought was, we have a solution, SmartCow Plate Reader. I'm just using it for the sake of a conversation. This solution is for LPR, MPR use case. How many of you knows what LPR and MPR stands for? So automatic license plate recognition or automatic number plate recognition, same stuff. Means it's a model that is able to recognize the number and the letters in a plate and the emoticons, because US guys decided that they want to put emoticons in plates, seriously. Don't ask me. Anyway, you know, I'm just waiting to see a plate in one of the shots we have with, we'll say, one of the most famous emoticons, let's say brown emoticons, like a pyramid. You get the, you know, sure, why not? So we said, okay, can we improve this solution without having to spend money and finding the right data set? Can we make the smart city smarter and simpler? Yes, we can. And so we started to work with NVIDIA Omniverse. Just as information for all of you, as long as you have a computer, laptop, desktop, whatever it is, that has an NVIDIA card with RTX capabilities, or you go on AWS, Azure, Google, whatever cloud you like, and you pick up an RTX instance, you can download Omniverse for free, because it's completely free, the individual version, and you can start playing with that. And by the way, Omniverse uses Python as a code. So in order to write code, you just use Python. It's super easy to start. So we start for that and said, can we make it? And this is what we built out. So we create what is called an extension. This extension is a native extension of Omniverse. What does this extension? The extension allows you to create a realistic plate attached to vehicles. So we can basically have what we call it environment randomizer and physics randomizer. Environment randomizer means what will happen to this plate if there's a condition like rain, fog, snow, ice, and so on. How the plate will change, no matter what the plate is, how it changes. How can we show this to the model? The other one is physics randomizer. What is the results of the plate if it has scratches, or if it has dirt, or let's say that it's been hit by mud, or it has dent. So it's basically, or basically, it's discolored. Have you ever seen a plate where the numbers are almost unreadable because they lost color? It's the physical world. We combine those are parameters. It's a low-code approach. I will show a couple of screens now. Those low-code approach allow you to play with that in a playground. You can see the results, combine those parameters, minimum and maximum, and pass them to Omniverse Replicator. What the Omniverse Replicator does, it takes all those parameters and generate a data set, size as you like. You decide how many images you want, and basically can create all the randomization there. From minimum to maximum, for each one of those parameters, we create thousands of images, each one with a slightly different position or variable in it, that allow me to create a super rich data set that I can use to train my model. Means, do I need a real data set from a real world now? Maybe yes, maybe no. Once it's that, well, once the synthetic data has been produced, we will do something else that I will explain in a couple of minutes. So this is a native extension, and also this extension is for free. So you install Omniverse, you go in the Exchange Marketplace, you pick up SmartCow LPSDG, the name of the extension, you install it, job done. What's the results? On your left, on my right, that's the real street outside of our headquarters in Malta. On the other side, that's the digital twin. It's not high quality. This is the low quality, just in case. So everything on this side, it's the real world. Now, if you see that, you see that the lights are almost the same. It seems almost the same hour. This is because in Omniverse, I can literally manage also this. I can add the GPS position, the hour, the minute, the seconds, the position of the sun, everything that is exactly like it is in the real outside world. And then I can create that. That means that my plate in the Mercedes becomes a real plate, like if it is in the real world. This is a screenshot. This is actually a live thing. I can stream a live video of this. So the number of cars, the type of cars, they actually are all live. They can literally drive to the street. And I can put the cameras wherever I like with the angles. So my smart parking system has exactly the right position with the cars that comes in and goes out. Front plate, rear plate. And that's actually what is the UI. No code. We write the code for you. No code, no needed. Because customers are not necessarily engineers. Customers are not necessarily machine learning engineers. Customers are not interested in writing code. I said at the beginning of my speech, it's all about basically what? Solving use cases. not going to a customer and say, hey, do you have a team of 30 people just to write code, just in case? So becomes the scratches. You see the plate that is a little bit scratched, like if someone actually incidentally was not fitting the parking. Or you can actually add the dirt and etc. So what's next? So we said, okay, you create the digital data set. What's next? Well, what's next is basically what we do is use an AutoML approach to find out, in our case, from your model, if you are another company, a third-party company, or NVIDIA models, to pick up the best one, and once we know the best one, train it against the synthetic data set. Once the synthetic data set is there, we can push it to the device management. SmartCow fleet tracker, for example. Why? Because this way we can actually push it down to the devices, to the cameras. And the cameras start to hit the ground, start to actually make the accuracy. The next step for us is simply develop a drift detector. A drift detector means I'm evaluating your model up to the point where I see that your model is actually going down, and then because of that, I understand that I have to take the drift, screenshot of the drift, and transform them again in digital assets. This way I can do what? I can recreate the data set, improve it with the drift that I was mentioning before, and push it back to the training. And with that, because we are out of time, I thank you all. If there's any questions, I will be here all day, so please reach me out. If you didn't like my talk, no worries. You will never see me again.
Thank you, Alessandro.
Thank you very much.